The title of our project is Why Robot the Artificial Nurse. Let me give you a brief introduction about my project. So, this project was made keeping in mind the current pandemic situation, and the inspiration to build this robot came mainly from three robots. The first one was the Moxie robot, which was built by Texas Instrument. The second was the USAP robot, and third was the telecommunication robot. Since all these robots' main task is to work in an hospital, I thought of combining the features of all these three robots into a single robot and adding few extra features which should make the robot useful in a COVID scenario. Hence, the idea to build Y-Robot was born. So, from the introduction, you might have understood that I am going to showcase a project something related to hospital. So, let me show you the problem statement. Like, why do we need this project? So, we all know that during pandemic like corona or generally in hospitals, the frontline workers such as doctors, nurses, compounders in hospitals are nearest to the patients. They all need to look after the patients without caring about themselves. Hence, doctors, nurses, workers have high chance of getting contracted by the disease, and medical personnel also fear for the disease and also for their health. So they are not ready to go to work in an hospital. And also during COVID, if a nurse wants to go near the patient, she had to wear a PPE kit, and once she has used it, she had to throw it, and it was a waste. We have to use it only once. So there was also cost problem. So what I have come up with is a robot that would help or assist the nurses. So here are the few images of the robot. So the first picture shows you the UV LEDs turned on. So these LEDs will help the robot sterilize. The next is the front view of the robot, and the third picture shows you the robotic arm and the camera. So let me show you the app through which I control the robot. So this is the app through which we can control the robot. So it has two buttons. So these are used to switch the robot between autonomous and manual mode. Next we have a joystick to control the robot. In the second picture we can see sliders which are used to control the arm of the robots, and also a gauge to see the sensor data. So let me show you the working or the prototype of our project. So in an hospital, the first thing the robot should do is it should go near the patient. So we have two modes of navigation. One is the manual mode. So here I am controlling the robot using manual mode. Like I am controlling the robot using the joystick using my smartphone. So this is controlled using internet. So the robot connects to the internet and I am controlling it using my smartphone. So I can control this robot from anywhere around the world. So this is the manual mode, as you can see in the video. Now we also have an autonomous mode. Here you can see the robot is standing still. I click a button and the robot start following the black lane path. Also it has an obstacle sensor. So that red box is an obstacle. As soon as it sees an obstacle, it will stop. So as soon as I remove that obstacle or the path clears, it will start continuing its path and it will reach the destination. That is, it will reach the patient. So by these two methods, we can make the robot go near the patients. So as soon as the robot reaches the patient, it will give a voice message that I am here to deliver the medicine. So after giving the voice message, what we can do is we can open the app and control the robotic arm and give the tablet. So here are the sliders. So each slider represent each joint. So I will be controlling the robotic arm and I will be delivering the medicines to the patient, as you can see in the video. So now the patient has taken the medicines. So after giving the medicine, we can retract back the robotic arm to its original position. So I am retracting it back to its original position. So after delivering the medicines, it will ask the patient to place their finger on the sensors. So it has two sensors, a heart rate sensor and a temperature sensor. So they are placed in a single place. So it will measure both heart rate and temperature at a time. So now it will stream the data of the sensors directly to my smartphone. So all is everything is working using internet. So we can get the data from anywhere around the world. At last, it will say a message for the patient to recover very soon. Now the robot has been near the patient, so it will have germs and viruses all over its body. So it needs to sanitize itself. So we have a use sterilization method by turning on the LEDs. So I'll click a button and all the UV LEDs will turn on and start sanitizing the robot itself. So it will sanitize itself and also it will deliver the medicines or any food or meals to the patients. So this is the working prototype of the robot. So this was the progress which we had made. Now, so this robot is not perfect. Like it has problems, like it cannot follow the black lane path at daylight, and it will face some problems while detecting the black lane path. Also, it is little bit slow due to internet connectivity issues, and also it needs active internet connections to work, and also it has low processing power, so it takes some time to process the data. And also the robotic arm is not so perfect so that it can grip tablets easily. So what we have thought of is to solve this problem. So we will be solving the problems faced in the first prototype and developing a second prototype of our product. So what we are doing is, instead of the microcontrollers which we had used, like we had used Arduino and Node MCU. So Arduino is a small microcontroller and Node MCU was used to connect the robot to the Wi-Fi. What I have come up with is, instead of these two, what we are using is Raspberry Pi and a ESP Go call. So what is the use of Raspberry Pi? It has lot more pins, so we can control more things, and also it has high processing power, Wi-Fi, everything built in. And this ESP Go call, it has a Wi-Fi, Bluetooth, everything built in, plus it has a SIM module, so we can insert the SIM. So the robot does not need any Wi-Fi or hotspot connectivity. It will run on its own if we insert a SIM. And the next upgrade which we are making is on the line following sensor and the robotic arm. So current version of the line following sensor will face some difficulties in the daylight. So we had used IR LEDs, and it would not detect the black line path in the daylight. So we have come up with a solution. So this is a LED light base, so it has a separate light source which it will detect. And also, instead of the gripper mechanism of the robotic arm, we are using a suction type robotic arm, so it will help the robot to pick the medicines easily. And instead of a speaker, so speaker was a one-way communication, only the doctor was able to give any messages to the patient. So we are using a tablet, so doctor can FaceTime and talk to the patients, also the patient can talk to the doctor. So we are upgrading it to this. And also, instead of just a heart rate and a temperature sensor, we have included a heart rate sensor, a oximeter, and also a contactless temperature sensor. The first one was a contact temperature sensor. Now we are using a contactless temperature sensor. Now this is the block diagram. On the left side you can see the old block diagram of the robot. On the right side you can see the new latest version block diagram. You can see the right side has fewer blocks and it's simple. So now, who are the users of this project? Like, who will buy this robot? According to us, there are three targets: hospitals, industries, and home. So the hospitals can buy these robots, and along with the nurses, they can send this robot, which will assist the nurses also, and which will reduce the work of the nurses. And the second one are the industries. So interested people can buy the rights of the robot and develop any extra features for the robot if they are interested. Or we can use it in homes, like for the old people, instead of using it for patients in hospitals, we can use it for patients or the aged people in home. So instead of appointing a nurse, we can use this robot for the old age people. And the cost to build the first prototype which we saw in the video was around 15,000, and the estimated cost to build the second prototype is around 25,000 rupees, and we are thinking of launching our final product for around 50,000 rupees. So this is all about our project. Thank you.